So taking a look at questions 16 through 22, which deal with the imaginary numbers and trying to write a polynomial, I'm going to go through a couple of them just to help you hopefully kind of jumpstart you as to what you need to do. So remember when we talked about the fact that if there is an imaginary answer, then it also has to have its conjugate. So when we talked about quadratics, we said that if the answer was 5i, then it had to be negative 5i as well. So first of all, we can add negative 5i to this list, okay? And then that means x minus 5i, x plus 5i, and x minus 1 are all zeros. And then what we need to do is we need to do out this distribution. So you need to do out your FOIL or your distribution to arrive at a polynomial to put there, okay? In 17, it's the same idea, but the algebra of 17 is a little bit worse than the algebra of 16, so I'm actually going to do out the algebra with you on 17. These may not be the actual problems that you have, but they're the same idea, okay? So if 7 is listed twice, then that means that x minus 7 to the second power is a root. And when I have x plus I, 1 plus I, we know we also have 1 minus I. So this becomes x minus 1 plus I and x minus 1 minus I. And this is possible as a kind of a thing that some of the kids may not have remembered from last year. But so we'll leave the x minus 7 for a second and we'll come back to it. But this can actually be written as x minus 1 plus I times x minus 1 minus I. If I redistribute, you're kind of bringing to your attention that there's this part can be distributed. So if I distribute my negative, I can then regroup them. Okay, so when I do that, I end up down here with the difference of squares. And so I'm going to take this to the side just for a second so that I can, and so because it's the difference of squares, I get x plus 1 squared minus I squared, which is x squared plus 2x plus 1 plus 1, or x squared plus 2x plus 2. And if you remember, when you do out x minus 7, you get x squared minus 14x plus 49. So the final step for you is what's in blue over here, and you're going to do x squared minus 14x plus 49 times x squared plus 2x plus 2, and I think hopefully you can do out that distribution at this point. Okay. In question 18, it says consider the following. Write the polynomial as a product of factors that are irreducible over rationals. Okay. So that means the first thing I need to do is figure out, well, does this factor, is there a zero that I know works? So when I look at this, I can tell you that it's quadratic-like. And so you absolutely can do the rational zero test where you do plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8 over plus or minus 1 and test those values until you find one that works. Okay. But in this situation, I also know that this factors to become x squared minus 4 and x squared plus 4 and x squared minus 2. Sorry, it's early in the morning. So irreducible over the rationals, this would become x squared minus plus 4 times x minus root 2 times x plus root 2. Product of linear and quadratic factors that are irreducible over the reals, okay, is this answer. This is this answer. So x squared plus 4 times x squared minus 2 is irreducible over rationals, means it cannot be broken down, factored anymore. Irreducible over reals still has an x squared plus 4, and then completely factored becomes x minus 2i, x plus 2i, x minus root 2, x plus root 2. Okay, so now we're starting to talk about given the 0 of the function is 4i. So this is a question I would say absolutely 19 is probably a question that you would see more likely as a bonus question for the test as opposed to an actual question. Okay, so keep that in mind, and I will tell you that up front. So question number 19 says that 4i is a 0. The problem is I can't put 4i into synthetic division to figure out what this is going to be, okay? But what I do know is that if 4i is a 0, so isn't negative 4i, right? And that means that x minus 4i times x plus 4i, well, those will actually work. And when I do out that distribution, I get x squared plus 16. If that went too fast, just pause the video, make sure you can get it yourself. It's fine. So, okay. So from here, I now know x squared plus 16, and I can do, that's not going to work out for me. It's not going to work out. I can do long division to find the last factor. And like I said, I know for a fact that this more likely than anything would be considered a bonus question for you on your actual test, but it's a really good challenge for you. It's a good kind of reach to make sure that you know what you're doing. So x squared times x gets me x cubed, and x times 16 gets me 16x. Both of these are subtraction. I'm going to need a pen color that's actually going to show up now. So x squared minus 16, and x, so x squared times 1, right? So this becomes way to pay attention, Miss B. This is negative x squared, because there's a minus here, negative x squared, which makes this negative 1 up here. Told you, it's early in the morning for me too. So then this becomes negative x squared minus 16, but I have to change the signs, and so you get 0. So this final product becomes x minus 1 times x minus 4i times x plus 4i, and therefore my zeros are 1, negative 4i, and positive 4i. All right, number 20, 21, and 22. Here we go, number 20. Write the polynomials of the product as linear factors. So again, this will factor into x squared plus 4 and x squared minus 4. This will factor even further into x squared, x plus 2i, x minus 2i, x plus 2, x minus 2, and then the zeros, therefore, are negative 2i, positive 2i, 2, and negative 2. Write the polynomial as a product of linear factors. Okay, we need to use the rational zero test to figure out a 0, so plus or minus 1, plus or minus 2, plus or minus 4 over plus or minus 1. And after testing, so I put it into Desmos or my graphing calculator and used the table feature to test it. I found that negative 2 is a factor, so we're going to put negative 2 in the box. And we're going to do 1, 4, 5, 4, 4. and I'm left with x cubed plus 2x squared plus 1x plus 2. And this actually will factor by grouping. So the product of linear factors is x plus 2 to the second times x minus I times x plus I. And remember, if you're struggling with kind of where I'm getting these plus or minus 2i's, 4i's, remember you can do x squared plus 1 equals 0. So you get x squared equals -1 and x equals plus or minus the square root of -1, which you know is plus or minus I. It's hard to read that, sorry. Okay. And then that means that my zeros, again, are -2, I, and -I. Finally, question number 22. Find all the zeros. So find all the zeros. Easiest way to find all the zeros is to start by saying, do the coefficients add? Well, does it factor? Right now, we don't know for sure. We can't quickly factor that. Number one. Number two, do all the zeros add to 0? Do all the coefficients add to 0? The answer is no. They're all positive, so that's not going to work out. So we need to do the rational zero test. So plus or minus 1, plus or minus 2, over plus or minus 1, plus or minus 2, plus or minus 4. And we're going to, again, throw them into Desmos or a graphing calculator and see if we can figure out a 0. All right, so we have a couple of choices, and because just for the nature of making sure everyone understands what they're doing, I'm actually going to take the -1/4 and put it in my box because I think it's good practice for you to see a fraction. Okay, so again, we got 4x cubed plus 8x squared plus 4x plus 8, and that will again factor by grouping. Thank goodness. So I get 4x squared times x plus 2 plus 1, and I get plus 4, sorry, I get x plus 2. So this gets me 4x squared plus 4 times x plus 2 times 4x plus 1. And then I know I can factor out the 4, so I get x squared plus 1 times x plus 2 times 4x plus 1. And then my zeros then become -I, +I, -2, and -1/4. Hope this helps for those of you who might be struggling with the Webassign. And take advantage of the opportunity to kind of just stop the video and just check your math, okay? Again, these aren't necessarily the answers in your Webassign, but if you understand how these questions work, then you can probably do your own Webassign.